Hello, my name is Kyle and today I'll be presenting memory allocation for Honey Potion. This is a project for the subject POC 1 of UFMG. Let's get started. Honey Potion is an Elixir to eBPF compiler. Amongst other things, it's responsible for managing the memory of eBPF programs. This can be challenging as Elixir is a dynamically typed language with automatic memory management, while eBPF is statically typed with 512 bytes of stack and a lack of common features such as malloc. The problem? We are running out of space. Some of our current benchmarks are in the limit of the 512 bytes and may go over with minimal changes. Given these limitations and quirks, we had to come up with a solution. Currently, in Elixir, we have full support for integers, atoms, tuples, and strings. Integers and atoms are represented within the stack, which as said before is limited to 512 bytes. They are represented in helper variables and program variables. Helper variables are responsible for helping in operations and the results of expressions, while program variables are the actual variables that are kept in the Elixir program and that are translated directly. Tuples and strings have their representative still in stack. However, the actual values kept within the string or within the tuple is kept in our heap. Our heap is represented by eBPF maps, which is the technology that we have to be able to access larger amounts of memory. Currently, we keep 3 heaps: string, tuple, and heap itself. String, as the name implies, is used for strings, allowing us to keep very large strings within it. The tuple map keeps pointers to the elements that are kept within a tuple, while the heap map currently keeps the actual elements of the tuple. Our variables are kept in 2 states currently, or they are generic or they are integers. The generic type is enumerated in orange, and you can see how it works. Currently, it occupies 12 bytes of memory, and the integer does occupy only 4. Well, this would commonly be solved using a weighted tree analysis for memory allocation. However, that can be both costly and complicated to implement. Thankfully, eBPF is limited in instruction, size, and looping. After all, eBPF does not support loops. As a result, we can use exhaustive methods. Our solution is more or less as described in this slide. First step is we're gonna keep the heap as it currently works, but we will be creating a stack that is smart. In this example, we can see that at the beginning we have 5 variables. The integers are represented by letters, while the generics are represented by numbers. So, in the beginning we have variable 1 and 2, and the integers a, b, and c being kept. At the next moment, we have removed variable 1 from use, as well as the integers a and c. However, variable 3 has started being used. We can occupy the space that variable 1 used to use for variable 3, while leaving some gaps where the integers were in the past. In case the memory gets full, like might happen in the red line, we can do a defragmentation by putting together the values. That way, we can fit more things, like happens in the last step, where we fit another generic and another integer, for example. Of course, the bounds represented there are not the beginning and the end of the stack, it may go on. So, what about branches? 2 different branches might have different stack states. To be able to manage these cases, we eliminate branch merging completely from our program. Consider this following case. Our tree on the left has branches and merges. However, the one on the right splits those branches so that we never merge. You will see that at every moment that would happen a merge, we actually have a duplication of the tree, like what happens in nodes 2 and 6. As a result, if we follow the purple numbers, you will notice that any singular branch that we follow is as if it was a single basic block or a sequence of instructions. As a result, our greedy solution works. So, in conclusion, I seek to implement a new memory allocator in Honey Potion to substitute the current stack to allow bigger programs by leveraging eBPF's limitations using a greedy solution. Thank you for your time.